In infrastructure and environmental projects, technical accuracy alone is rarely enough. A design can be correct and fully compliant, yet still face resistance if stakeholders cannot clearly visualize what it will become. This is where visualization plays a vital role, helping projects to be understood, discussed, and ultimately accepted. In this video, AXANH presents the story of an infrastructure and environmental project where 3D visualization and animated walkthroughs were used to translate complex engineering data into a clear and transparent visual narrative. Through visual communication, the project established a shared understanding between engineers, decision-makers, and the local community from an early stage. The project involves the design of a waste reception and transfer facility serving local businesses, including functional buildings, waste storage and sorting areas, retaining structures, perimeter fencing, internal traffic circulation, and site grading. Located in a suburban area close to existing roads and residential neighborhoods, the project required careful control of visual impact and traffic organization. Therefore, clear and accessible communication is essential to ensure transparency, clarity, and trust among all stakeholders. From the beginning, the design aimed to ensure efficient operation while remaining compatible with waste handling equipment and established processing workflows. Particular attention was given to earthworks and material handling, especially in areas with shallow rock layers and complex interbedded soil rock conditions. The team delivered complete technical documentation, including drawings, cut-and-fill quantities, and geological cross-sections to support construction planning and investment decisions. At the same time, the information needed to be presented in a visual language that non-technical stakeholders, such as local authorities and nearby residents, could easily understand during permitting and public consultation. The engineering and design team was responsible for both technical development and data coordination. They produced comprehensive site layouts, grading plans, elevation adjustments, cross-sections, excavation analyses, and soil rock profiling. Data from multiple sources, drone surveys, field measurements, borehole investigations, and CAD surveys was collected, standardized, and synchronized to form a reliable foundation for design and visualization. Geological analysis played a critical role in identifying top-of-rock elevations and interbedded layers, which directly influenced excavation volumes and construction strategies. Beyond technical drawings, the team developed detailed 3D models and simulation videos that placed the project within its real-world context. By simulating views from surrounding roads and key vantage points, the visuals helped communicate design intent clearly, allowing stakeholders to understand how the facility would appear in everyday conditions. Despite thorough preparation, the project faced several challenges. The site's complex terrain and geology required multiple surface models and continuous data verification. Inconsistencies between borehole data and drone survey results made it necessary to recalibrate surfaces and recalculate cut-and-fill volumes to ensure accuracy. Time pressure added further complexity, as design development, data updates, and technical verification had to progress in parallel with preparation for community meetings. Most importantly, traditional technical drawings alone were not sufficient to communicate the project clearly to non-technical audiences. At the beginning, the team received a technically dense design package with layered terrain information. The challenge was not only to model it correctly, but to help stakeholders visualize the actual spatial experience of the completed project. Civil 3D served as the technical backbone of the workflow. Drawings were carefully reviewed, layers organized, and elevations and site boundaries verified to preserve accuracy before moving into three-dimensional modeling. Precision, rather than speed, was the priority at this stage. The data was then transferred into SketchUp, where uneven terrain and varying elevations were refined to ensure buildings integrated naturally with the landscape. Roads, access routes, and environmental elements were connected logically, while the model structure remained clear and flexible to accommodate design changes. With the model finalized, Lumion was used to translate technical information into a realistic spatial experience. Materials reflected real construction conditions, and camera paths were designed as a continuous walkthrough, allowing viewers to experience the project as if they were moving through the site themselves. At this stage, technical drawings became an immersive visual narrative. The results were clear. Visualization helped identify terrain-related issues early, reduced revisions, and enabled faster, more confident decision-making. During the public meeting, initial concerns about scale, appearance, and traffic impact shifted once the visualization video was presented. Participants could clearly see the project, turning abstract concerns into constructive discussion. By the end of the meeting, most opinions moved towards support or positive neutrality. The visualization video became the central communication tool between the investor, engineers, and the community. It reduced misunderstandings, built trust, and improved engagement without changing the core engineering solution. It was not just a 3D video. It was a tool that helped the project be understood correctly and accepted earlier. This project highlights a simple but powerful lesson. In infrastructure and engineering, helping people see early is often more effective than explaining repeatedly. Visualization is not only a presentation tool, it is a strategic asset for communication and risk management. Follow AXANH to discover more projects where engineering clarity and visual storytelling work together to move ideas forward.